All right, this is our lesson on rational inequalities. We've already done a lesson on polynomial inequalities. This is our lesson on rational inequalities, which is similar, but obviously it's different since it's a different type of function. Okay, so the steps to doing this are very similar to a polynomial inequality, except there is a first step that polynomial inequalities didn't have. Rational inequalities, which look like this, okay, so on and so forth. Rational inequalities look like fractions. When you look at them, you're like, oh, that's a fraction. This is a rational, okay? I didn't circle anything. This is a rational. So rationals have denominators, and we know that a denominator cannot be equal to 0. So what we have to do is we have to find any restrictions. That's what they're called on the domain, okay? So restrictions are what x cannot be equal to. Since they cannot be equal to that, they will never be included in our solution set. So they should always be open points, okay? So we're never going to include those. And then from there, it's the same thing as polynomial inequalities. You're going to get the inequality equal to 0 or just pretend that it's equal to 0. It has to have 0 on one side and then just a single fraction on the other. And we'll see what happens when it's not. And then you're going to turn it into an equation, solve it. Once again, these are called the critical values or the zeros. Critical values. I squeezed it over there. Or zeros. Okay? So there's restrictions. That's what x cannot be equal to. And then there's those critical values, which are our zeros. Okay? You're going to use the critical values and restrictions to make a sign chart, and then you're going to either test points or use the multiplicity trick to find where it's positive or negative after that, and then write your solution set. That's it, okay? So let's go ahead and jump into a problem here. So it has to be equal to 0, check. Well, not equal to, greater than or equal to 0. 0 has to be on one side and a single fraction on the other. Check, check, check. And then now what we have to do is we have to find our restrictions and our zeros / critical values. So let's start with our restrictions. We know, I'm going to write restrictions here, but then I'm going to not write that, but just so that we have it clear in our notes. Restrictions, x cannot be equal to 3, because if x was 3, we'd be dividing by 0, which is not okay, okay? Then we have to find our critical values. So we're going to set our fraction equal to 0 and solve. When you set a fraction equal to 0 to solve it, okay? So here's my fraction. A over b, ooh, look at that, equal to 0, okay? In order for a fraction to be equal to 0, the numerator has to be equal to 0. The denominator doesn't, right? In fact, the denominator can't be. The numerator has to be equal to 0. So to find our critical values, the shortcut is that if it's a fraction, instead of setting the whole fraction equal to 0 and solving, you can just set the numerator equal to 0 and solve, right? So what I'm going to do to get myself through this process is that as long as I have the numerator factored, I'm never actually going to have to show that step. I can just like do it in my head. So what we're going to do always as our first step before we even find restrictions is we are going to make sure that the numerator and denominator are both factored. So I'm going to factor my numerator. My numerator factors to x minus 1 times x minus 1, or x minus 1 squared. And then my denominator is x minus 3. And I have greater than or equal to 0. So my restrictions, still x can't be 0. And then my critical values, or my zeros, okay, are x equals 1. And x equals 1, which I'm not going to write twice because it's just 1. All right, so now you're going to take those numbers, you're going to put them on a number line. 1 comes first, then 3. Okay, now restrictions, x cannot be equal to 3. It is not included. Now the 0, we have to decide if we're including zeros. So if you look, it says include values greater than or equal to 0. So we are including 1, okay? All right, now we have to see, are we including these values? Are we including these values? Are we including these values? Okay, so we're gonna test a point in each, and then I'll also remind you of the shortcut way, and then I'll do the shortcut for the rest of the video, okay? So I'll try x equals 0 here, okay? When you're plugging in 0, make sure you plug it into all 3 places, okay? Or here, 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 whichever one you want to do. I like the factored form, as we've learned in my other videos. So I have a negative times a negative in the numerator, which is a positive, over a negative, which is a negative. Now I'll test a point in between 1 and 3. I'll choose x equals 2. So I have a positive times a positive in the numerator, which is a positive, over 2 minus 3, which is a negative. So I have a negative again. And then x equals 4 I'll choose here. In the numerator, I have a positive times a positive. When I say a positive times positive, that's 3 times 3, right? Positive. And then 4 minus 3 is positive, so I get positive. Now look at your inequality. It's greater than or equal to. So here's where it's equal to, and then I also want greater than, so these values right here. So writing that in interval notation, I have 1 as a solution. And then union, I also have values greater than 3, not including 3 though. And that's how I write it. If you wanted to only plug in one value, I would start by saying I'm going to plug in 0, okay? Please remember that this is the same thing as x minus 1 quantity squared over 3. So the multiplicity of the 0 of 1 is 2, which means I'm keeping the sign, or yes, I'm keeping the sign. So this is where x equals 0 is, which was negative. If I'm keeping the sign as I jump over 1, it's staying negative. And then 3, oops, why did I write 3 like that? X minus 3. It has a multiplicity of 1, so I'm going to change the sign as I jump over 3, so that's becoming positive. So that's how I'll do it from now on, right? Instead of doing the math multiple times. Okay. So that's the gist of the lesson. It does get a little bit more difficult though, because if you look here, it's not just one fraction on one side. So stick around or fast forward to that if that's what you need help with next, okay? All right, so I'm gonna get this completely factored. It's already 0 on one side and already one fraction. So just be careful with this factoring. We have x plus 3 times x minus 2 in my numerator. And then in my denominator, I have x plus 1 quantity squared, greater than or equal to 0. All right, so I'm gonna get my restrictions. X can't be negative 1, that's an open point, okay? That's my restriction, okay? And then my critical values, CV, critical values, are my zeros. So that is x equals negative 3 and x equals 2. And those could possibly be included in my solution set dependent on the inequality symbol. All right, number line. Negative 3 comes first, then negative 1, and then 2. All right, so negative 1 is definitely not a solution. If I plugged in negative 1, I'd get a 0 in the denominator, which is not a solution, all right? All right, then negative 3 and negative 3 and positive 2 I am including because it says include your zeros, right? And now I'm gonna pick a value to test. So I'm gonna pick 0, x equals 0, which falls right here. So that's where I'm gonna put my sign once I do it. Plug in 0 here, here, and here, right? So 0 plus 3 is positive, 0 minus 2 is negative, so that's a negative in the numerator. And then 0 plus 1 squared is positive. So these values are negative, okay? So now to get the other ones, once again, follow along with me. I need to jump over 2. So I'm going to look at the multiplicity at 2, the 0 of x minus 1, right? Sorry, the factor of x minus 2, what the heck was that? Has a multiplicity of 1, which is odd, so I'm changing signs. Now I need to jump over negative 1, so that's the factor of x plus 1, which has a multiplicity of 2, which means I'm keeping the sign. To jump over negative 3, the multiplicity is 1, so I'm changing the sign because that's odd. Now I'm going to look at what I want. I want greater than or equal to, so those are my positive values. So these are positive and these are positive. And now I'm going to write my solutions. So that is negative infinity to negative 3, bracket, because I'm including my negative 3, union, bracket 2, include 2, forever. And there's your solution set. All right, next one. The denominator's not factored this time, so we gotta factor that. X plus 1 over x. There's a GCF of x. X times x minus 5. Less than or equal to 0. All right, so our zeros set the denominator equal to 0 and solve. So we have, our restrictions our restrictions. Set the denominator equal to 0 and solve. That's x can't be 0, x can't be 5. And if you just write your restrictions are x equals 0 and x equals 5, that's fine, because you're saying that they're restrictions, but I say can't be, so I remember to keep it open. And then my 0, or my critical value, is x equals -1. Okay, put those on a number line. So we have -1, 0, 5. -1, 0, 5. 0 and 5 are restrictions, so they're open. And then -1, it says less than or equal to 0. So I am including my zeros, which is -1. All right, pick a point anywhere. I can't pick 0 this time. Wah, wah. I'll pick x equals 1, which is in this section. So if I plug in 1 in the numerator, I get a positive number. And if I plug in 1 in the denominator, I get 1 times -4, which is negative. So all of these are negative. All right, jumping over 5. 5 has a multiplicity of 1, so I'm going to change the sign. Jumping over 0. 0 has a multiplicity of 1, so I'm going to change the sign. Jumping over -1, x plus 1 has a multiplicity of 1, so I'm going to change the sign. Here I want values less than or equal to 0, so these are less than, and these are less than. And here's where it's equal to, right? So now I'm going to write my solution set, -infinity to -1 bracket union 0 to 5, not including 0 nor 5. Okay. All right, next one right here. So on this one, we have a 0 on one side, but we do not have one fraction. So I need to make this one fraction. Like, that's not difficult to add two things, right? So we do need a common denominator. So I'm going to put this over 1, voila. And now I need my least common denominator. My least common denominator is x plus 4. So I'm going to multiply this by x plus 4. And whatever I do to my denominator, I have to do to my numerator. So now I'm going to write my LCD, which was x plus 4. And I have less than 0. And I'm going to write my new numerator. So this is my new numerator, which is x minus 2 plus 2x plus 8. Combine like terms to clean it up. That's 3x plus 6 over x plus 4. Less than 0. And now I want to factor it if factorable. This is factorable. There's just a GCF of 3. But I'm still going to factor it because I like to be consistent. But if you didn't, life would go on. Okay. X plus 4 down here. Voila. Okay. So restrictions. X cannot be -4. Zeros, x equals -2. All right. Now I'm going to put these on a number line. All right. I have -2 comes first and then 4. -4, I like writing them like this so that I can, there we go. -4 is a restriction. So that is, oops, I wrote them wrong on my line. It's -4 and -2. There we go. That would have thrown me off quite a bit. All right, so -4 is a restriction, so that is not included in my solution set no matter what. And then looking at your inequality symbol, I just want values less than 0. I don't want to include my zeros. So I'm not including -2 either. All right, pick a point to test. I'm going to do x equals 0, which lands right here. So I'm going to get this sign. Plugging in 0 in the numerator, I get 2 times 3, which is 6. Plug in 0 in the denominator, I get 4. So I have a positive over a positive, which is positive. All right, I'm going to use multiplicity. I'm going to jump over that -2. -2 comes from the factor of x plus 2, which has an odd multiplicity, so change your sign. -4 comes from the factor of x plus 4, which is an odd multiplicity, so change your sign again. Look at your inequality. I want values less than 0. So those are values in between -4 and -2. Good? Okay. All right. Did I make a mistake? No. X minus 2, x2, 4, 8. 8 minus 2 is 6. I'm looking at another teacher's answer key, but I'm right. I don't think they're right. I'm right. Okay. Moving on to this next one. Is it the last one? No. Oh, but it's close because that one is just completely different. All right, so this one is also not equal to 0. Not also, but this one now is not equal to 0. So first I have to get it equal to 0. So I have x minus 3 over x plus 1. Minus 1 is greater than 0. And now it's just like the last one, right? I don't have one fraction. So I need to get a common denominator. So I'm going to put this over 1. My common denominator is x plus 1, so I'm going to multiply this by x plus 1, which means I have to do the same to the numerator. I'm going to write my lowest common denominator, which is x plus 1. And then my new numerator is all this, all right? So I'm going to write x minus 3. Make sure you distribute a negative 1. So that's minus x minus 1 greater than 0. Combine like terms. That's negative 4 over x plus 1 greater than 0. All right, so I need my restrictions first. My restriction is x can't be negative 1. And then my critical values, there are none. Because I go to set my numerator equal to 0 and solve, my numerator has no x in it, right? So there is one restriction, and that is x can't be negative 1. So negative 1, no way, okay? So I'm going to pick a value to test. I'm going to choose x equals 0. Plugging in 0, I have a negative 4 in the numerator no matter what. 0 in the denominator, I get a positive, so this is negative. If you look at the multiplicity of x plus 1, it is odd. So as I jump over that, it's going to change signs. Look at your inequality symbol. You want to know where values are greater than 0, right? We're looking at this, we're looking at this or this, right? We're not comparing it to 1. We're looking for values greater than 0, which is right here. So our solution set is negative infinity to negative 1. Okay? All right, that's it for today's lesson. You can go ahead and get started on tonight's homework.